Hello, fellow Scratchers! I'm Griffpatch. Welcome back to part 2 of our How to Recreate Geometry Dash in Scratch series. Whereas episode 1 focused on creating that scrolling level, this episode is where it gets really fun as we introduce multi-level platforming, reworking the player's jumping mechanic to support gravity, find out how we handle collisions with the floor, ceiling and walls, and how to avoid those unexpected Scratch glitches. Whoops! No problem, we will fix that too. Yes, I've got oodles to teach you today, so I hope you are ready for some serious fun. Guys, let's get scratching! We start by loading up our completed projects from episode 1. But before we add anything new, it's worth going to the File menu and saving this project as a new copy. Now, I'll rename the new copy as Episode 2. We do this before every new episode, so that if we make a mistake, we always have a backup of our work from Episode 1 to go back to. Excellent! And here we go! Let's begin by adding some platforms to our level. These want to look something like this. A grid of black squares. Now, how I create these is to click into the level sprite, making the sprite visible on the stage, and then in the Costume tab, make a brand new costume. This means we can see the exact size of the costume that we draw. Set the fill color to black, and the outline color to pure white. Now that's important as white will be our solid collision color. Now keep the width set to 4. Then we use the rectangle tool to drag out a square while holding the shift key that is 9 by 9 grid squares in size. Then adjust the result until it reads 38 by 38 pixels. Perfect. Let's place it into our level. Click Copy. Next, duplicate the first level costume, and we click Paste. And there it is. We can bring it down to sit on the ground by dragging or nudging it with the arrow keys on our keyboard. To change this into a grid of black tiles, make sure we click on the Selection tool, and then hold down Alt and Shift before dragging the platform to make a perfectly aligned copy, refining the position afterwards using the up and down arrow keys. Now, what's really cool is that if we select both of these shapes together by dragging around them, then the Alt-Shift trick still works and duplicates both at once. Aha! This trick can be repeated on a bigger and bigger scale, allowing us to build up very large platforms really quickly. Cool, right? Okay, so that should do for now. Let's delete that last costume, and let's see how this platform looks in the game. Smash that green flag! Here it comes! Ah, well, of course. What did you think would happen? Our jumping code from episode 1 has no concept of a platform or what to do with it should we collide. So the game continues as if it didn't exist. Not a problem. Stop the project. Then make sure to make the level sprite visible on the stage, because we're now going to talk about jumping and gravity. Our previous jumping scripts can be found in the player sprite over here, and this really was the most basic jumping script ever. We can press space right now and see the player move up and then down on the project stage. But everyone knows that when we jump, the motion the player is expected to follow is an arc. The colliding with a platform should then break the fall. Well, okay then. Delete that old jumping code. Blah. To allow us to simulate gravity, we need to keep track of how fast our player is falling. So make a new variable. Name it speed y, and declare it for this sprite only. That is, the player sprite. Okay, let's have some fun and simulate a jump. Bring in a set variable block, setting the new speed y variable to 28. Now that should represent quite a fast upwards movement. But over time, they should be pulled down by gravity. So separately, we change speed y by, and let's try a value of -4, as the gravity in Geometry Dash is really quite strong. Finally, we actually move this sprite using a change y by block and drop in that updated speed y variable. Great, now we can test this by clicking the second change y script to run it. Oh, wait, okay, so that didn't jump, and that was my fault, as we should have clicked the set speed y script first to actually set speed y to 28 to initiate that jump. Whoops! And then clicking the update script launches the player upwards. So keep clicking the update script and we can watch the player go up, slow, and return to the ground in a smooth arc. Very exciting. All we need to do now is prevent them from passing through the level when they touch it. First off, we need to detect if a collision has occurred. If we are touching a colour, and the colour that we chose for solid collisions is pure white, then great, we have collided. We don't want to stay this way, so we should lift the player sprite up until they are no longer colliding with the level. We can do this with a repeat until block. Repeating until we are not, that is, we are no longer, touching the colour white. And all we do is move the player upwards a little at a time, using a change Y by 1 pixel. This will repeat over and over until we are no longer touching white. It's the perfect time then for a quick test, so hit that change Y script again, click, and there you go. Do you see the player drifting slowly upwards until they are no longer in contact with the floor? Yeah! Of course, after a collision, we really want to reset the player's speed Y to 0, since their downward velocity has been stopped by a collision. Run that a couple of times and you'll see the speed Y is now more under control. Great! Well, we can try a small jump. Set speed Y to 28, and here we go. Up and down. Oh dear, I clicked the script again while it was still running, and doing that actually stops the script rather than starting a new one. Let me try that again. Up and down, and good. The collision is fixed. But this is still a little ugly. I mean, who wants to see the player dipping below the ground like this actually in the game? Not me. It would be much nicer if all this fixing up of collisions could be done without the player of the game seeing it happen at all. The problem is that whenever we loop around like this, Scratch assumes we are creating an animation, and it refreshes the screen here, each and every time we loop around. What we want to do is tell Scratch that this bit of code is to be run without refreshing the screen. And it just so happens, under the My Blocks category, if we make a new block, let's call it Move Out of Level, we have the option to run without screen refresh. Well, how about that? So click OK, and then we can attach this new define block to the top of the code we don't want to animate. Then, having defined these scripts as move out of level, we can simply drop the new block inside that if here to have it run whenever we detect a collision. Let's see how that looks. Just click once to set speed Y to 28 for a new jump, and then start tapping the change speed Y script. Up and down, and boom! We no longer see any overlap, or the dreaded rising up of the player. It all happens in a single screen refresh. So, in effect, it's instant. Now that is cool. We can also try it elsewhere on the screen, and yeah, it just works, as long as we are touching the colour white. Okay then, let's see if we can get this gravity into our game. If we look at this when flag clicked script, we currently have a wait until touching colour block. Now this is waiting for the player to hit a spike. What we want now is to run some scripts while we are waiting. So we'll split the script here, and first we'll make sure to reset the player's speed Y, not to 28, but to 0. This ensures we don't begin the game jumping or falling. And then we'll make our game loop. Repeat until. And again, we repeat until we are touching the spike's colour. That isn't white, it's the off-white yellowish colour, if you recall. That means we no longer need that wait until block, and then we can reattach those end of game scripts below the repeat. Cool! Right, these gravity scripts. Now we could bring them directly into this loop here, but for clarity, I'm going to make another custom block to keep our code nice and readable. We'll name it Player Movement. And we might as well tick the run without screen refresh, as this all wants to run in a single animation frame. So these scripts are the player movement scripts, and we can make use of that block in our game loop here. Perfect! It's testing time then, so hit the green flag, and off we go. Ooh. Okay, wow, let's play that again. So this is good. the player is sitting on the floor and he's not falling through it. But when we smash into a wall, boom, we are teleported up onto the top. Now that's actually expected, as we coded all our collisions to be fixed by raising the player up until it was no longer colliding. What's really sweet though is how the player neatly falls off the platform at the end. That looks awesome. And yeah, spikes still work too. Great. Now, did I mention we can't jump anymore? Yeah, we did delete the old jump script after all. Right, first question. When should the player be able to jump? Obviously not while they're in the air. Yep, it's when they touch the ground. Or we could say, just after we detect a floor collision, and that code is here. So, after moving back out of the level, drop in an if check, and we'll look for when the space key is pressed. I've had a lot of people asking how to make this project mobile friendly, so let's also bring in a mouse down check. That's true when the mouse button is clicked or the screen is tapped on a mobile device. We'll need an OR block, as we don't mind which of these is pressed, either will make us jump. And then set speed Y to 28, just like we did before when testing gravity. Let's test it! Squish that green flag! And woohoo! We are able to bounce off the floor and off platforms too. Ha! Can't say I've got any better at avoiding those spikes. Actually, with the new gravity and jumping mechanic, it's way more of a challenge jumping the triple spikes. I'm not even sure it's possible. Challenge accepted! Oh my gosh, much too early. Yeah, too late. Early again, come on! Oh man, I've got to nail this one. Yes, I knew it. I am the master. Or perhaps I'm just too easily pleased. Okay though, enough of that. We've sorted floor collisions, but what about ceiling collisions? Now, if I click into the level costumes and just temporarily move our platforms higher up, watch what happens if we jump into them from below. Yeah, rather than bumping our head, we fly up through the platform instead, and we can't be having that. Now obviously, it's the same problem again, that every collision is fixed by moving the player upwards until they no longer are colliding. The solution then would be to switch things around when we are travelling up into a collision. And that is when the player speed Y, SY, is greater than 0. And then instead we move out of the collision downwards. Sounds simple enough? Okay, so this existing code is handling a downwards collision. We can surround them with an if-else block, like so. And the condition is that speed Y is less than. If speed Y is less than 0, a downwards collision. Therefore, we can move out of the level upwards as before. But if we are not moving down, then we must have been moving up into the collision. Now, rather than rewriting lots of similar code, we'll reuse the same move out of level block again. But we won't include the jumping code on the end, since we don't want to allow jumping after colliding with the ceiling. Not in this game mode, anyhow. We just need a way to tell the move out of level block which way we want it to move out of the level, upwards or downwards. Right-click on the define block, or long press it if you're using mobile. And then choose Edit. Then we can add a numeric input and give it the name dy. That's the amount to move in the y direction. And so, rather than changing y by 1, we can now replace that with the new dy input variable. Then, looking back at where we use this move out of level block, the first one can be told to move upwards out of a collision by setting the input value to 1. And the second one, when we bump our heads, can move downwards with a value of -1. Does that make sense? Pretty neat, right? So watch this. Ground collisions are working. And bumping our head no longer bounces us through, but sends us smashing right back to the ground. Excellent, that is a relief. You know, I feel like we are making really good progress here. The collisions are almost done. So where do we still have a problem? Yep, it's with face-on collisions. In this scenario, we don't want to try to pop them up or down out of the level. No, this should be game over right there. But telling the difference between wall, ceiling, and floor collisions is not actually so straightforward. For example, this collision. Is it a floor collision or a wall collision? I guess it all depends on how we got here. And usefully, our speed y variable can tell us just that. So, in this example, if we are able to move the player out of a collision within the previous speed y range, then all is good. It's a platform collision. But if we can't move them out within that speed y range, then we can assume this was a wall collision and it's game over, dude! Now, before we fly into trying to code this up, there's one more gotcha that I have to mention. Sometimes we'll find that our hand-drawn levels can be, how shall I say it, a little wonky, or God forbid, Scratch itself rasterizes our perfect platforms misaligned. Yes, that does happen too. Well, this kind of collision also ends in, game over. Not cool. We'd do well then to widen the allowed safe zone just a tad, say by 4 pixels above and below, and this extra legroom will allow us to safely skip over these small problems and make our games far less frustrating for the player. Nice, let's do this. Okay, find the define move out of level block. It's going to be easier if we start over. First, allow for that 4 pixel safe zone by moving into the collision by 4 pixels. That's change y by, and then we multiply change y by -4 multiplied by dy. Then we begin our loop, this time with a repeat block. We need an addition and the speed y. Now that's the distance we need to cover the safe zone. Except, hold on, this can be a positive or negative value depending on if we're moving up or down. Luckily though, we have the abs block for this situation. This stands for absolute, and it happily flips any negative values back to positive ones. -8 becomes 8, and +4 stays as 4. Very useful indeed. So drop the speed y into that, and in turn that goes into the addition. Now we just need to extend this y distance by the 4 above and 4 below. That totals to 8 pixels. Great! Within the loop we continue to change y by dy, as we did before, but need a new if to check for when we are no longer touching the colour white. Simply reuse the not touching colour from the previous script. Well now, if this is true, we must be out of the collision. Hurrah! So set speed y to 0, and we are done. So conclude here with a stop block, choosing to stop this script. That will break out of this repeat loop and end the entire custom block. However, if we don't find a point of no collision within this repeat, well then that is our game over. Now, I don't want us ending the game sunk slightly into the floor, so we can tidy this up just a little by duplicating the change y script from the top of this and dropping it down here at the bottom. -4 multiplied by dy. There. And lastly, broadcast. A new message. Game over. Nice. I'll just discard what's left of the previous script as this one is done. Almost ready to test. We just need to handle the game over event. So scroll over to our main game loop. Here it is. The scripts below the repeat are the existing game over scripts. To run these from 2 places, spike collisions and wall collisions, we can separate them off and then reattach them under a when I receive hat block for the game over event. Finally, drop another broadcast to game over after the main game loop ends here, and we are done. This is super exciting. Guys, smash that green flag. Here we go, straight into a wall, and oh boy yes, that was most certainly game over. And that too, brilliant. Floor and platform collisions are still working fine, and jumping down into walls is detected correctly. Oh, but hold on, do you see that? On game over, the player should stop in their tracks as the level scrolling slows. But now, that seems to be a little off as the player glides out of sync with the level. Nasty. Now this has been caused by us moving the game over scripts from the main green flag script into a separate broadcast receiver. I shan't go into the details now exactly why this is, but to fix it, all we need to do is move the change y block up above the change scroll speed block within this repeat loop, and the problem should magically go away. And yes, that's it. Much better. No more sliding around on death. Hey, if there's any of you Scratchers out there who would like a stab at explaining why this fix works, then I'd love to see your answers, so drop me a comment under the video. Script execution order is probably one of the hardest things to grasp in Scratch, and once mastered, really frees you up to finally take control of your Scratch games. Oh my, I even managed that triple jump again, woohoo! Well, I'm sad to say we are drawing to a close on this episode. We've reached a point where, given a bit of time and effort, we could actually start to build some pretty neat Geometry Dash levels. Why, we might even try to recreate the beginning of the famous Stereo Madness? But wait, Griffpatch, I hear you say, there's still so much left to do. Yes, I know. We need to add those beautiful travelling particle effects, get the player rotating, how could we have not covered that yet? Not to mention creating a start screen and a method of restarting the game when we die. Yes, much to do. But wow, haven't we come a long way in just 2 short episodes? Guys, if you enjoyed this video, please would you carefully and respectfully feed that mini thumb-shaped creature lurking under my video? It's incredibly hungry and a simple click will do them the world of good. Also, so as not to miss my next exciting episode, please consider subscribing to this channel and checking that cheeky bell icon to ensure you are the first to know when a new video drops. Let me know how you're getting on in the comments under the video, and be sure to have the project added to the official Scratch Studio also linked under this video. That just leaves me to say thanks for watching, have a great week ahead, and scratch on, guys!